guys, welcome to biopsy. Today we are going to discuss about characteristics of benign and malignant neoplasms. So let's start the video. First we think about benign and malignant tumors. First thing in our mind comes is growth rate. So in malignant tumors, growth rate is very high. They grow rapidly. While benign tumors, they grow slowly, so their growth rate is low. But there are too many exceptions in this case, so this is not a reliable discriminator between malignant and benign. Okay. We are going to discuss mainly about three characteristics of the tumors. First is differentiation and NEOPLASIA. Second is local invasion, and third is metastasis. So let's start with the first one. First is differentiation and NEOPLASIA. So guys, what is differentiation? Differentiation refers to the extent to which neoplastic parenchymal cells resemble to the corresponding normal parenchymal cells, not only morphologically but functionally also. And what is NEOPLASIA? Simply, it is lack of differentiation. Okay guys, first we talk about benign tumors. Okay, benign tumors, they are well differentiated tumors. What does it mean by well differentiated? As we talked in the its definition, that they are similar to the normal parenchymal cells both morphologically and functionally. This is the image of a lipoma. On the left side we guys can see normal adipocytes, and on the right side we can see lipoma. So we can't differentiate between these two cells because they are morphologically similar and also they are functionally also similar. The only difference is lipoma, there are many cells present which causes tumor. Okay guys, you can see they are normal, is physically similar. Other thing is mitosis. What is mitosis? We all know that normal cells, all the body cells grow by dividing, and they divide by the mechanism known as mitosis. And this is the full figure of a mitosis. And how we can see mitosis in these cells? We take tissue biopsy and see under the microscope. We can see if some cell is undergoing mitosis, and in this phase, we can see this phase is called mitotic figures. So we can see these figures in microscope, and we can say that this cell would be going under the mitosis. As we all know, normal cells grow very slowly, so there are very less chances and rare chances of seeing mitosis in normal cells. So while in malignant, they grow very rapidly, so there will be increased chances of seeing mitosis, obviously. As we are talking about benign cells, benign, there is rare normal configuration because they are slow growing, obviously. So it will be rare to see a mitotic figure in those cells. But although we can see sometimes or rarely. Okay. Other thing, if we talk about malignant, there are three options right now we have. One is poorly differentiated, other is well differentiated, and in between those two types there is moderately well differentiated tumor. Okay guys, first we talk about well differentiated tumors. What does it mean by well differentiation? As we talked earlier, it would be similar to the normal parenchymal cells both morphologically and functionally. So it will be similar to the parenchymal cells. So how would we know is that malignant or benign tumor? So their malignancy is revealed by invasion. If the tumor invades, it could be malignant. Okay guys, we go for example. Its example is well differentiated adenocarcinoma of thyroid. So its follicle is exactly similar to the normal thyroid follicles, where other side is poorly differentiated malignant tumors. In poorly differentiated, it is no or poor evidence of differentiation. So morphologic appearance, it is the highly predictive of malignant nature. We can see the biopsy under the microscope and see the cells. Its morphological feature will tell us that this tumor is malignant only. In well differentiated cells, as we talked earlier, they are similar to the normal parenchymal cells both morphologically and functionally. So this cell would be retaining their function. Example is tumor, but this could be a problem sometimes, obviously. Why? Imagine that the tumor is present in the endocrine cells. As it is retaining its function, so it would be secreting hormones, and if some hormone would be increased in our blood, it would cause problems, obviously. But other thing about the tumors is we can measure the level of hormones in the blood. Yeah, so we can check the treatment response and growth of tumor by the level of hormones in our blood. So these examples of well differentiated cell is squamous cell carcinoma. Squamous cell carcinoma, what does it do? Squamous cell, they produce keratin over the skin. Okay guys, while hepatocellular carcinoma, this is cellular carcinoma. Hepatocellular carcinoma, what does it produce? Is bile. Obviously, it retains their function and their secretion or keratin formation will be increased. While highly anaplastic and undifferentiated cells, they lose their specialized functional activity. But that is not that much issue because they lose. Okay, they lose. Sometimes they acquire new, which is unanticipated function. We don't want that function they acquire and they start doing it. Like some tumors express fetal proteins. Obviously they are fetal proteins, so it would not be present in adult body. But if there is tumor and they acquire this kind of function, then they will secrete fetal protein in our blood. And other thing is, the other line is there that some tumors express proteins that are normally found only in the other type of cells. Now it is a bit complicated line, isn't it? We guys can't understand that, but we can understand that with an example. There is example of bronchogenic carcinoma. This is a very interesting tumor, guys. Bronchogenic carcinoma. This tumor can produce either corticotropin, either parathyroid like hormone, either insulin, either glucagon. So, and other things also, but these are the main things which bronchogenic carcinoma can produce. So it explains this, like some express the proteins that are normally found only in the other type of cells. Like parathyroid hormone is only secreted by the parathyroid gland, isn't it? Well, insulin only by the pancreas. Okay guys, but in bronchogenic carcinoma, the cancer cells secrete these proteins. Now we see other morphological changes of the cancer cells. Okay, first morphological change we are going to see is what is pleomorphism. What is pleomorphism, guys? Its exact meaning is variation in cell size and shape. In a tumor, there will be small cell to the giant cells. Both will be present simultaneously there. Okay, what and how will we see tumor giant cells? Tumor giant cells may have single huge polymorphic nucleus, or they have two or more large hyperchromatic nucleus present in them. As we have mentioned about tumor giant cells, you guys must have heard about giant cells elsewhere. Yes guys, yeah, you are right. We can remember the most common, most important giant cell as Langerhans giant cells, which can be seen in tuberculosis. So Langerhans giant cells, it is, and how will we differentiate between Langerhans giant cells and tumor giant cells? Yes guys, you are right. Langerhans giant cells, it is made of macrophages, while tumor giant cells is normal cells. And Langerhans giant cells, it is not malignant. It would have normal nuclei. While as we talked here, it will be a huge polymorphic nucleus or two or more large hyperchromatic nucleus there. So second morphologic feature we are going to see, abnormal nuclear morphology. Abnormal nuclear morphology. What is NC ratio, guys? NC ratio is nucleocytoplasmic ratio. The ratio between nucleus size and cytoplasm. Okay. In normal cells, it is 1:4 or 1:6 normally. While in malignancy, as we know that in malignancy, the nucleus of the cells is enlarged. So nucleocytoplasmic ratio will be 1:1. We guys can understand how much large nucleus will be present in that cells. Other thing we can see about nuclear morphology, the chromatin. The chromatin will be clumped and distributed along the nuclear membrane, as I have drawn this diagram to show you guys that chromatin is clumped and distributed along the nuclear membrane here. Or also it could be more darkly stained than normal. Yeah, possibility would be more darkly stained, as there is more DNA material there, it will be more darkly stained. Another nuclear morphology, we can see that large nucleoli could also be seen in this type of tumor cells. Other morphologic feature we are going to see about mitosis. We have talked earlier about mitosis, as this would be undifferentiated cells and fast growing cells. There we can see many cells in mitosis, which says to us that it is high rate of proliferation there. But we can't, if we see mitosis in a biopsy and we can't, many mitosis, and we can't directly say that this could be a malignant cells. That means mitosis doesn't always mean malignancy. There could be possible that some cells will be exhibiting rapid turnover, like epithelium of the gut. It continuously shed off and grows rapidly. So there could be possibilities that mitosis can be seen frequently. Other in hyperplasia, there are increased proliferation of cells. So we can't say that only mitosis. But atypical and bizarre mitotic figures, it is a morphologic feature of malignancy. If atypical and bizarre mitotic figures are seen, we can say that this could be a malignancy. Okay guys, other morphologic features, loss of polarity. We know that tumor cells grow disorganized manner, they grow blindly and they grow in disorganized manner. So their orientation is disturbed. To whom? To each other and to basement membrane. So they would be just growing and tumor, there is a mass of cells. Okay, as we talked about the first characteristic, we need to know about what is metaplasia, what is dysplasia, and what is carcinoma in situ, and what are the difference between them. First we talk about metaplasia. What is metaplasia? It is adaptation to chronic injury, and also we can say that replacement of cells to other type of cells. Oh, okay, I think this could work. Okay, other type of cells. I know you guys can't understand that, but it would be understood by a very best example of metaplasia is Barrett's esophagus. What is Barrett's esophagus? In diseases like gastroesophageal reflux diseases, what happens is acid is regurgitated in the esophagus frequently, and as we all know that esophagus has which kind of epithelium? Which kind of epithelium esophagus has? Stratified squamous epithelium. Okay, but this stratified squamous epithelium is sensitive to acid, isn't it? It is sensitive, it is very sensitive to acid. But when happens this regurgitation of acid very chronically, like many times it is exposed to acid. So what does esophagus think? Like, I don't want to get bullied by this acid this many times. So what he will do, he will change this stratified squamous epithelium to the intestinal epithelium. Intestinal epithelium, which is columnar and mucus secreting, and which is not sensitive to acid, which is resistant to acid. So now esophagus would not be bullied by acid. So in this esophagus would be named as Barrett's esophagus. Yes guys, so this Barrett esophagus, there is intestinal metaplasia happens, which I have explained this here, and this intestinal metaplasia happen, but as there is chronic injuries to these cells are prone to malignant transformation. Yes guys, they are prone to malignant transformation. And other example of metaplasia is also there, squamous metaplasia of bronchial epithelium in smokers. In smokers, there is continuous irritation of mucosa because of their what it is called, the smoke and other things which they inhale and goes into their bronchus. So their epithelium is there is squamous metaplasia seen in the epithelium of chronic smokers. Other second is dysplasia. Dysplasia literally means that disorders growth. Okay guys, dysplasia, and it is also a pre-malignant change. Dysplasia is a pre-malignant change. It could be transformed into malignancy anytime. In dysplasia, cells may exhibit high NC ratio, considerable pleomorphism, large hyperchromatic nuclei, and loss of differentiation. These all are the feature of neoplastic malignant cells. Okay guys, but this is not that much we can term as that malignant. We'll talk after that how we can term a tumor malignant or benign. So in what is dysplastic cells, mitotic figures are also more abundant. Okay guys, this is, I have also drawn one figure. I know that it is not that good, but it can at least explain what is dysplasia. This is the normal epithelium as I have written here. This is a dysplastic epithelium. In dysplastic epithelium, you guys can see this focus on these cells. Okay guys, it has no larger nucleus, so it has high nucleocytoplasmic ratio. It also has loss of differentiation, as the normal skin cells, they are hexagonal in shape, but these have doesn't differentiated. So this will be, I have drawn them circular, and also on the surface they need to get flattened, but they are not getting flattened and not forming the keratin. So this is the loss of differentiation and hyperchromatic nuclei. And although there are other things about dysplasia that we need to know, although dysplasia may be a precursor to malignant transformation, but it does not always progress to cancer. Dysplasia is a precursor, but it does not always go to cancer. If the environmental stimuli which is chronically disturbing the cells is removed, then dysplasia can be reversible, completely reversible. Moderately severe dysplasia can be completely reversible. And what other thing is there, metaplasia leads to dysplasia sometimes, but not all the metaplasia is dysplasia. Yes guys, not all the metaplasia are dysplasia. And the third thing we need to know, what is carcinoma in situ. What is literally meant? Cancer, it is yet to invade. The cancer which is not invaded yet. Carcinoma in situ, severe dysplasia involving full thickness of the epithelium but no penetration. There is severe dysplasia that we can tell that this could be cancer, malignancy, but it hasn't invaded yet. This display all the cytologic features of malignancy. Okay guys, and the thing is, what we know, that cancer arises from the accumulation of mutations. The mutations in gene accumulate, and when they reach the needed mutated genes, it causes full-blown cancers from in situ. So the time interval for evolution of full-blown cancer from in situ, it is the time required for accumulation of all mutations that are needed to induce a fully malignant phenotype. So guys, this video has already been about 17 minutes, and I will be explaining other two characteristics in the second video. Thank you guys for being with us. If you like our video, please like, it matters to us a lot, and subscribe also guys, please. Thank you so much guys, have a good day, bye.